Hello everyone, welcome back to my YouTube channel, Nuclear Process Designer. It is Abdurrahim Babatunde Pola for Nuclear Process Designers. So welcome back to this YouTube channel that is dedicated to process design, modeling, and design of processes and systems. So today I brought another exclusive model that I want to showcase to you guys in case if you want to create or develop model like energy power system model with MATLAB or Simulink. So I'll be showing you this model and how I did it on this video. This model is for renewable hydrogen microgrid system. So um, it has majorly if you check this model you can see the reference for microgrid system in MATLAB and some other model system. So I used it to develop this model. We have the wind turbine system, and we have a PV power system that is harnessing sun during the day and night from the plant from the solar plant. Then the wind is taking the wind energy, and the system is connected to battery system for energy storage during excess period. And okay, this one is also having alternative battery system where I'm going to be storing this energy is not given, because from the model that I was using to start the model, this is how it is being done. So when I worked on this and I got it right, then I added the wind turbine system to it, and try to do the we connect the route so that I will be charging during the off peak period and discharging during the peak period when you need the electrolysis power. So the output is the load of the whole system. Electrical system is the electricity system that you have over here, and this is the system to monitor some key variables like the voltage, the current in the line, and from here you have the voltage and current from the electricity stack, so you know the amount of power that you're getting from the stack or electricity stack, and the flow rate of hydrogen. So firstly, the wind system is following this trend based on the wind speed, and at this period of time for 24 hours, this is the trend of the wind speed. You can change it later just to see the influence, maybe based on location or something. So if I just want to use an average value of the wind speed, I can switch to this, and you can be seeing the trend using this scope. Then you have the solar following the same pattern. You can see the solar output. Then for this we have the turbine. So currently, in order to do turbine, you have to use some simscape blocks. So I'm having like 4 turbine, and although turbine give me some time to do, we have the wind coming from there, from that place that I explained. Then you have this pitch angle controller to control the speed of the rotation of the turbine. This is the wind turbine, the wind vane, and this will generate torque that will be transferred to drive a DC generator that you have here. So both of these DC generator and the wind torque, they are gotten from the library, like specialized electronic libraries. One of the old MATLAB blocks, specialized power system library. They are one of the old MATLAB blocks. I think, let me show you where they are. I found them around there because one of the problem of doing this is so you can find it under this electrical machine of the specialized power system. So you can see some AC machine. You can use this machine just like DC machine to model electrical generator. You can see from here. You can use the permanent magnets, or this one is permanent magnet synchronized machine. That's mostly for a 3-phase unit or 2-phase. But I want everything to be actually DC. DC system, just like it's just a mini system to generate like 10 100 kg 1 kg per day of hydrogen. So I don't want it to be big system. So most of the system is actually DC. You understand? Then the wind farm, the wind turbine is taken from here. It's just a torque. The output for the model is a torque. You understand? So in order to connect multiple model in Simulink, you have to know the input and the output, the relationship between them, so you know where to connect the next output to. You understand? So that you have your whole system. So you can see this is a model, Simulink model. So I can connect the domain directly because this is the old, it's not, it's the old Simscape blocks. You understand? So when I have the power, this is the armature current circuit, that this where you have the output of the DC motor. So you connect your positive here and your negative here, and you have a both current measurement to measure the current and the voltage measurement to measure the voltage. And this line is also connected to this interface. This one is to transfer the old voltage line to the new electrical domain in Simscape. You understand? So I can easily connect the power out to the Simscape. Then you have this cycle controller. This one is mostly like a DC-DC converter. It's just to vary the voltage of, because this generator might be producing a very high voltage or very low voltage. It's just to stabilize the bus voltage, that is, because you have multiple connection here. You can see multiple connection. All the output power is connected to multiple sources and they're having different voltage. And if you want to stabilize it, you should use a converter to do that. So that's the work of this software. So it's going to be varying, getting the ratio of the voltage. You understand, with time, and you can even use it to vary to get maximum power out of the system. So this is for the wind turbine system, and this is where you have the control system to control the pitch angle. You can see the controller here. This is the the speed per unit capacity of the controller 1.2. So I'm going to be controlling this based on set points, maybe 1 or 1.2. You understand? So I even want it to be 1.2, but let me just leave it in 1. Then I'll be seeing the result over here as I'm running the model. Then for the system, I have like 5 turbines, because you can easily use this. You can only use it for one turbine, not the entire system. You won't be able to get it right. So like 4 turbine stack turbine, so that is connected in parallel to generate electricity. Then for the PV panel, you use the electrical domain from Simscape. I will have done a very big video, but people are not watching a very big video, so that's why I just do this summary, so that people can just see the way I did the connection and have some insights on the design, on development of their model. And if you have any question, you can always contact me. You understand? So so for this electrical system, you can find you can see this is a free cell electrolyzer. Then you have this solar cell, so you can have your PV array using this solar cell that you have here. So from there you choose any standard PV array that you have, or if you have the parameters of your PV array, like the diode, saturated current, you put it there. Then the irradiance that will be measured from the sun. So the irradiance is the input to the PV array. You understand? That is the sun rate per unit area. You understand? The sun intensity. You understand? What energy intensity per unit area. Then you have the quality factors and the series resistance, the parallel resistance of the PV array. Then you have the numbers of panel that you connected. This one is 60 in series, just to stabilize the voltage. You understand? You have one in parallel, so it's just one. Everything is it's just 60 in series. Then other parameters are specified as follows. Then you have this is the current that is flowing from the PV So because the PV will also be supplying different voltage at different point in time, and you want to stabilize the voltage and even maximize the power that will be coming out of the PV, you can use this MPPT controller that will be varying this DC-DC converter. You understand? So that's what I did there, and the code for the MPCC, you can see enable MPPT voltage source. So this one is basically from the source. You can easily check it out. The code here is just to maximize the power by using if statements. And if the power is not high, it's going to return to the old voltage and calculate a new cycle for the DC-DC converter that will maximize the power. Then the settings for the DC converter is box and box. So that means the voltage can increase or decrease in the output voltage, and the efficiency is constant, 95% efficiency. So then the whole thing is connected to the battery system. The battery system is 100% charged. You also get it from the electrical domain. You understand? Then the voltage is 260. The current direction that is moving forward and backward. The internal resistance is also given, and the dynamics is given. This is the settings that I use for the voltage, or for the parameters of the battery. Then there are some initial condition that the battery should satisfy when it is running in dynamics. That is, if you have like 60,000 ampere hour charge, that is like fully charged in our case. You understand? So you can create some kind of thing. This is the charge. For example, if I enable this charge measurement port, so if you measure the amount of charge that you have inside the battery, then you can use it to calculate the capacity of the battery by dividing by the total numbers of charge. This is the 1 divided by 60,000. Yes. So you'll be able to get the percentage of charging. You understand? And this one is also for the numbers of charge. You can copy it from here. You understand? I'll put it over here. Then this one is where you want to control the discharging rate of the battery. It's just like a table, like a 3D array table that you can use to look at how the voltage of the cycle controller that the battery will be supplying to the external bus with respect to the current that the solar is releasing and the wind farm is also releasing. So you'll be able to maintain the energy transfer rate to the electrolyzer. So you can see this is 300 when you have high battery capacity and high solar and high voltage. Then as you are moving lower to lower energy, okay, this one is for lower current. You have 330 that the battery is going to be supplying, and when you have high current, it's going to return to 45. So as you are going down, when the battery is getting lower, it's going to be reducing. You understand? It's going to be reducing when the battery is getting lower. You understand? So that's the rate. So that to maintain the energy transfer, it's just like a controlling system for the battery. Then the voltage is going to be maintained. You understand? So that the rate at which the energy is going to be sent from out of the battery will be controlled. Then the outlet is connected to this system for the battery. You have the circulation of the water that is going to the battery. It's just like a typical electrolyzer model. You have the pump that will be you measure the flow here, and you add some calculation to convert the flow into height based on the size of the tank that you have. So this is to calculate, to convert it to kg, meter cube per kg. Then if you do this, okay, sorry, this will convert it to kilogram per second. You understand? For meter cube per second to kilogram per second. Okay, meter cube. Okay, this one is converting it from kilogram per second because this is mass measurement. You make it to the mass, you connect it to the mass measurement. Then this will convert it to kilogram. This is a gain that you use to convert it from meter cube to from kg to meter cube per second. Then you integrate it, it will give you the time. So this is the initial condition. It's already 1.5 meter cube initially in the tank. So when you integrate it with time, so the flow of the accumulated water will be given. Then from here you can convert it into area. You can convert it to height, sorry, water height, by multiplying, dividing by area. You understand? In gain. Then the height is now sent. You can see the T. Okay, the level is sent to this place to control when it is fully full. You can see when the level is 200, then it's going to reduce the flow of water. But when it is 170, it will not add the flow. They want the level to be 170, so you can use this like a feedback control for the flow of water inside the electrolysis stack. You understand? Then you have the temperature of the water is sent to this electrolysis stack. The volumetric flow rate is also needed, that is sent to this place. So for the generation of hydrogen, then this block will take the voltage that you have supplied from our bus and the current, and this purge lock if there is any excess accumulation of inert in the system. You understand? So, and the pH value, I think we are not using pH value and volume of purging because we are not purging, basically purging. Then it used to calculate the hydrogen that will be produced with time, and then you can connect it to this from the hydrogen reservoir. This one is actually not, it's just because of the model and the properties of the hydrogen that will be produced. You can specify here, you understand, with respect to temperature, the enthalpy, and the dynamic viscosity, and so on. Then then you have the mass flow rate that will be sent from here. So this one is to convert it into gram. You understand? Because it is into kg, sorry, because it was it will be produced in gram. Then once you convert it to kg here, because this one is taken, you can see the unit here. Okay, is in kg, is in kg. You understand? So the area mass flow rate is going to be sent here in kg. Then you have this one is going to measure it, the flow rate that is coming, that you just like, even you can even send it directly from here, but this one is just to convert it into maybe the property you want to get it in volumetric flow rate. You understand? So but you can easily bypass it if you want. So then the measured mass flow rate and the energy flow rate is sent to this place to calculate the accumulated time of hydrogen that is being produced during the simulation run. So it is initially at 0, then as time goes on it's going to increase. You understand? Then it is recorded here in mAh. Then the flow is sent to this into this storage tank. You understand? So that's for the process. So if you run it now, after running it, if you check the result from the wind farm, let's start with the wind farm. You can see the power produced from the wind farm at different points in time. Then you can see the individual power, and the the voltage, the MPPT controller for the wind farm. You can also see this trend of the angle, the pitch angle, to to stabilize the speed of the generator. So then if you go to the battery, the PV, the solar PV array, you can see the trend and the MPPT charge controller. Then you can see this voltage tree. Voltage tree from the solar PV array. So all these metrics are what you are going to be using to see the performance of your system with time, so that you can design it to be efficient and make it work the way you want it to work. You understand? So then for the overall system, if you check this place, you see the key current that is flowing. This is the current from the battery, solar, wind, the overall current. You understand? Is given. This is the battery percentage. Sorry, battery percentage. Then the current from the solar, the wind, and the overall current is given over here. Then if you go to this place, you see the flow. You can see this is 70, and you can see this place. This is the current that is flowing through the line, and this is the voltage. It is connected here. This line, I'm supposed to annotate it, but sometimes you annotate it's just difficult to, I don't know, I'm not sure. Doing saying this, if I want to do it here, I'm supposed to write a name for this variable. You put a name there for the signal. For all the signal, you're going to put a name there. So that is for this system. So for the other system that I created, the connection is done after the before the battery, so that the wind farm and the solar PV system can be charging the battery when you need it to charge it. Because for this case, for this other one, you can't have it like that, because this is a diode to prevent backflow. You understand? So from where I got it, the source model for this is this is how they did it. So I think we can make it better by making the battery to charge the by making the renewable energy system to charge the battery when you have excess power. You understand? So I connected it over here, and you have this one is battery is sent to the duty controller. So you have another battery controller here that I'm using inversely. So because the control has to be inverse, because before the idea was when you have high flow of the current from the renewable energy source, the battery rate should reduce. But in this case, when you have high, you should charge, release a lot of energy out of the battery, so that more energy will be stored inside the battery. You understand? So that's why I have to reverse the control. So inverse the control or something, the logic of the control. So you can see this trend now is quite different from what you have before, and this is actually using not the voltage reference, but the cycle, the duty cycle for the DC-DC converter. You understand? So, and if you go to DC-DC converter, it's actually set to be duty cycle, not voltage reference, but also the voltage can increase or decrease, and this is the efficiency based on this vector of the current. So for 50 ampere is 96, for 130 is 100, for 90 is 93. So when the current is dropping, it's going to affect the energy loss in the DC-DC converter, just to make it realistic. Then this is the state of charge, that is the percent the energy level in the battery. So when it is less than 30, it's going to stop the simulation. So so to prevent that problem. So then you have this wind turbine system, and everything is given just like we have it, and this one is just to measure the voltage, so that there is nothing wrong with the circuit. So I'm going to show you the result of this one too. I think I ran it. So if you open this result, you can see it here. It's coming up and down, and you can see the trend of the this one is for the state of charge, which is 70, but this one is charging. You can easily control it to charge it, or to discharge the battery when you need, so that you just save the energy, or just to balance, like let's just say grid balancing, all those kind of things. You can do it for this kind of model. You understand? Then this is for the solar, the wind farm. This is for the solar, while this is the total current that is going to the load, which is the electrolyzer system. Then if you go to this place, this is also producing 70 kilogram per hour. You understand? And the voltage is given, and the current is also given. You understand? So then You have this 1, 2, 3, 4. You can see 5 wind turbine, and the power that each of them is giving is also available. So I think with this, I'm going to be able to show you how to create a model or develop a model for renewable green hydrogen microgrid system with MATLAB Simulink. So with this base case, you can use it to do a lot of things. You can model it into electrolysis analysis. You understand? You can do grid balancing, you can do sensitivity analysis, you can do control of the electrical units, electrical system, and the electrolyzer system. So if you are working on this similar case, this can serve as a base case scenario, base case model for referencing for your model and the likes. So you can also contact me on our YouTube channel to learn more about this. And if you want us to work on a specific topic on process modeling or system modeling with MATLAB, you can send me the topics. I will work on it and upload the video. So thank you very much for your time, and see you on the next one.